welcome to Math Molecules. In this tutorial, we would be covering applications of Pythagoras theorem, some important word problems where you would learn how to apply Pythagoras theorem. Let's first recall the theorem. Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is a right angle triangle which has sides A, B, and C, where C is the hypotenuse and A and B are the legs of the triangle. By Pythagoras theorem, we have A square plus B square equal to C square. A detailed explanation about Pythagoras theorem is given in my previous video. Please find the link for the same in the description. Now let's move on to the applications. The first application would be to find the third side of a right angle triangle if we know the other two sides. For example, the three sides of a right angle triangle are ABC as shown in the figure. Here A is the perpendicular, B is the base, and C is the hypotenuse. Case 1 would be where we have to find the hypotenuse when the perpendicular and base is given to us. Let's see this. Here A is equal to 6 cm and B is equal to 8 cm, and we have to find the hypotenuse, which is C. So by Pythagoras theorem, we have C square is equal to A square plus B square. Substituting the value of A and B, I get it as 6 square plus 8 square, which is nothing but 36 plus 64, which is equal to 100. So I have C square equal to 100. 100 can be written as 10 square. So I have C square equal to 10 square, which means C is equal to 10 centimeter. Or I can write it as C is equal to square root of 100, which is again equal to 10. So we have C is equal to 10 centimeter. We found the value of hypotenuse when we were given the perpendicular and base. Moving on to the second case, we have to find the base where perpendicular and hypotenuse are given. Let's draw the right angle triangle. Okay, so what is given to us is the perpendicular, which is 12 centimeter here, and the hypotenuse, which is 13 centimeter here, and we have to find the base. By Pythagoras theorem, we have A square plus B square equal to C square. Let's substitute the values. 12 square, I do not know what is B, so I leave it as such, B square, and then C square is nothing but 13 square. So from the equation, I have got 13 square minus 12 square. B square is equal to 13 square minus 12 square, which is nothing but 169 minus 144. We get it as 25. B square is 25. B is equal to square root of 25, which is nothing but 5. So I have B equal to 5 centimeter. I get the base as 5 centimeter here. Now let's move on to case 3, where we have to find the perpendicular, where the base and the hypotenuse are given here. Now in this triangle, we have to find this perpendicular A, while the base is 3 here and the hypotenuse is 5. Again, by Pythagoras theorem, we have A square plus B square equal to C square. Now we do not know what is A, so we leave it as such. B square, I write 3 square, and for C square, we will substitute and write 5 square. Now A square is equal to 5 square minus 3 square, which is nothing but 25 minus 9, which is equal to 16. So A square equal to 16. A is equal to square root of 16, which is nothing but 4 centimeter. So here I get A value as 4 centimeter. So in this application, we learned that how to find the third side if any two sides of a right angle triangle are given to us. Before we move ahead, let's quickly recall Converse of Pythagoras theorem. If the square of the length of the longest side of a triangle is equal to sum of the squares of the other two sides, then we say that the given triangle is a right angled triangle. Let's apply this to check if the triangle is a right angled triangle. Now in this example, we've been given the measurements of the sides of a triangle. Now we have to find if the given triangle is a right angle triangle. How do we go about with this? First, what we have to check is if the square of the longest side is equal to the sum of the squares of the other two sides. So here the longest side is C, which is 25 centimeter. So let's first find the square of the other two sides, a square plus b square, which is nothing but 7 square plus 24 square, which is nothing but 7 square is 49 and 24 square is 576. When I add them up, I get 625. 625, we know that is the square of 25, which is nothing but equal to c square, because we also have c square equal to 25, which is again equal to 625. I mean c square equal to 25 square, which is equal to 625. So here we have satisfied the condition that a square plus b square equal to c square, where the square of the largest side is equal to sum of the squares of the other two sides. So we can say that yes, this particular triangle is a right angled triangle. Now let's take the second scenario. Okay, let's try this one out. So we will see that a square plus b square is equal to 9 square plus 16 square, which is nothing but 81 plus 256. When we add up, we get 337, while c square is equal to 18 square, which is equal to 324. So a square plus b square is not equal to c square. Therefore, this particular triangle is not a right angle triangle. So, using the converse Pythagoras theorem, we were able to identify which triangle is a right angle triangle. If it satisfies the condition a square plus b square equal to c square, then we say that the given triangle is right angle triangle. So this is one of the applications of Pythagoras theorem. Now let's see the next application. To find the length of the diagonal of a rectangle or square. Here in this example, a rectangle has a length of 12 centimeter and a breadth of 9 centimeter. What is the length of its diagonal? So let's draw a rectangle. Consider this rectangle as A, B, C, D. And let's find the length of this diagonal. Sorry, I couldn't draw the diagonal properly. So BD is the diagonal. It should be a straight line. Now we have to find the length of BD. Now if you see this triangle BCD, triangle BCD is a right angled triangle. Okay, it's a right triangle because we know that all the angles of a rectangle are 90 degrees. So we have a right angle triangle. Now BD becomes your hypotenuse, right? BD becomes the hypotenuse, and this is the base and this is the perpendicular. Now we can easily find out what is BD square equal to DC square plus BC square by Pythagoras theorem. So we have it as the length here is given as 12 and the breadth is 9. So I have got 12 square plus 9 square, which is nothing but 144 plus 81, which I get it as 225. Therefore, BD is equal to square root of 225, which is nothing but 15. So I get the hypotenuse as 15 centimeter, which is nothing but the diagonal. So the length of the diagonal is 15 centimeter. Now let's go ahead with some more word problems on Pythagoras theorem, which are quite popular. The height of two buildings is 34 meter and 29 meter respectively. If the distance between the two buildings is 12 meter, find the distance between their tops. So we have two buildings here standing like this, and there is a smaller building here. So this is 34 meter and this one is 29 meter, and the distance between them is 12 meter. Now we are supposed to find the distance between the tops, between this point and this point. This is the distance we have to find. So let me name these points here: A, B. AB is one building and CD is another building. So what I'm going to do is I'm just going to complete this line here, okay, and maybe mark it as E. Now this complete AB is 34 meters and CD is 29. So here I get a sort of a rectangle. ECDB is a rectangle. If this is 12 meter, this is also 12 meter. What is this small distance AE? AE. AE would be equal to complete AB minus CD, because we are going to have CD and BE are going to be same. This is also 29. So AE is equal to 34 minus 29. What do I get here? 34 minus 29, which is 5 meter. So AE is equal to 5 meter. So now I have AE is equal to 5 meter and EC is equal to 12 meter. I have to find out AC. If you see that, this is a right angled triangle. I can apply Pythagoras theorem here and find out AC square is equal to 5 square plus 12 square, which is nothing but 25 plus 144, which is 169. AC is equal to square root of 169, which is equal to 13 meter. So we were able to find this particular distance between the tops of the two buildings, which is nothing but 13 meter, applying Pythagoras theorem. Let's see this last example. Here we have a ladder 13 meter long is placed on the ground in such a way that it touches the top of a vertical wall 12 meter high. Find the distance of the foot of the ladder from the bottom of the wall. Let's get the picture of this. Now this is how it looks like. There's a ladder which is 13 meter long, is kept inclined to a wall which is 12 meter high. Now we have to find the distance between the foot of the ladder and the bottom of the wall. So this is the distance we are supposed to find from here till the bottom of the ladder. Now let's assume this distance to be x. When we see this image, it appears like a right angle triangle. So it is a right angle triangle, and so we can apply the Pythagoras theorem. We've been given the perpendicular and the hypotenuse, and now we have to find the base. So by Pythagoras theorem, we have 12 square plus x square is equal to 13 square. I have assumed x to be the distance between the bottom of the ladder and the bottom of the wall. So we have x square equal to 13 square minus 12 square, which is nothing but 169 minus 144. which is nothing but 25. Therefore, we have x is equal to square root of 25, which is 5 meter. So we get this distance as 5, meter. So we have the distance of the foot of the ladder, this and the bottom of the wall would be 5 meter. So these were few important applications and examples which we covered related to Pythagoras theorem. I hope this tutorial was helpful in understanding the applications of Pythagoras theorem. Thank you so much for watching Math Molecules.